All right, it started. So, like the very first question includes two concepts. It's one of the concept is from chapter number 4, which is your hardware, software part, and sorry, one of the concept is from chapter number 3, which is your hardware part, the first two parts, and then after that, from part C, it's chapter number 1. So, if there is a question which will be involving multiple concepts, we are only going to be dealing with those which are related to chapter number 1. See, so let's look into the very first question. A computer stores data temporarily in random access memory, which is your RAM. So when you see the word RAM, you should understand that it's usually going to be referring to your chapter 3 concepts. Eh? So if you look at it, the very first part, it's like, okay, RAM is one example, give one other example. This is not a part of your chapter number 1. So you will be directly skipping that. This is chapter number 3, chap 3. And just like that, your part B is also chapter number 3. So you'll be skipping that too. Now, from part C onwards, you see questions are again back to discussing the same. This is chapter number 1. जो पहले दो questions है, those were from chapter number 3. But starting from part C, now we are only going to be dealing with chapter number 1 question, जो कि आपके data representation, binary, hexadecimal, and all those concepts. Eh? So now part C says that the denary number 19 and 230 are converted to binary numbers to be stored in the RAM. Convert the two denary numbers to binary numbers. So now we will be revising a few concepts too. Now the thing is, in your schools there are two methods which are usually taught to students for converting between denary and binary. एक तो ये होता है कि you consistently divide the value by 2, list down the what do we call it, your remainder and the answer you're getting, and at the end you just go from the bottom and just count up all the remainder values. That one method is correct, but it's very difficult. I personally used to hate that method. Why? Because there is a very big chance you make an error. Don't want to create a scenario where we might end up making errors, right? Because this paper 1 is a very easy paper, and usually people do fear that 15 marker question. But I can assure you, if you score like 70 up here, you just need barely 50 marks for that A star, which means that even if you mess up the whole 15 marker question, which after this I will be doing 15 marker questions too, inshallah, in this series, so you will be feeling that that's not difficult at all. I can assure you that, inshallah. But even if it is for you, don't worry, क्योंकि अगर आप यहाँ से ही मार्क्स इतने अच्छे उठा लो ना, so even if you do lose marks there, you're still good to go. So the method which I usually use is कि हम ना, we have analyzed this one thing, that whenever there is a binary register, let's say, okay, by the way, I'm taking this class like after maybe a few days, so इस वजह से थोड़ा graphic tablet के सामने आदत फिर से नहीं हुई या क्या. Let me set it up, let me keep the back there. So yeah, so अगर हम यहाँ पे ना एक register, we know this is a register. A register is a type of you can say a column, or maybe अगर आपके घर के अंदर there is a rack, and in that rack you can store multiple books. Maybe you might have your history book, then followed by science, computer science, English, maths, biology, or whatever. So every one slot can occupy a single book, right? Just like that, in your computer memory, what happens is कि एक हमारे पास इस तरह का slab बनता है, which has multiple locations for binary values. And then what we do is that we kind of assign every slot one value. So like this can be 1 0 1 1 0 0 1. This is like some random values. See? Now, the important point here to understand is, if you have watched the recorded lectures, you will know that every value in this specific register has a specific denary value, which means कि हर जो हमारे पास slot है, like this position, has a specific denary value, and that value is different from this, is different from is different from this, is different from this, and this. So now, what are those values? So those values basically start from 1, and because we are moving in a in base 2, like we know binary is what? Binary is base 2. Base 2. Considering binary is base 2, तो हम जितना left पे move करें, we are basically incrementing the powers in terms of 2. So like 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. For this, if you have watched the video, I gave you this short formula, which was value equals to base raised to power position. So in this scenario, we know that if I want to find the value for the very first one digit specific register, it is going to be the base for this value, because considering it's binary, is going to be 2 raised to power the position. This is position number this is position number 0. Why is it 0? Because remember, whenever you're dealing with computers, this is very important. This is a very important point, especially in your paper 2. This is very important. Whenever we are talking about the first element in computer science, the very first element in computer science. We are always going to be stating that कि computer के लिए the very first element is not one. Like मैं बोलूँ ना, if I want to count from something, how many chairs do I have? Yeah, I'm sitting at the first table. So I maybe conventionally might say okay, I'm at table number one. But whenever the computer wants to say that, let's say it's doing the very first task or very first thingy, तो वो उसको number zero देगा. So for computer, zero is the conventional one. Conventional one. So whenever we say the conventional one, first, second, third, इसके लिए होते हैं 0, 1, 2, 3. So like if I have to count up to 4, the computer is going to be like 0, 1, 2, 3, 4, which means for computer, this is 5, fifth operation. But for me, considering I will be like 1, 2, 3, 4, तो मेरे लिए ये होगा fourth operation. So this is very important point to note क्योंकि इस scenario में भी वही बात हो रही है कि पहली position की value is going to be 2 raised to power 0, which is 1. And it's going to be 2 raised to power 1, which will be 2. Then it will be 2 raised to power 2, 4. 2 raised to power 3, 8. And this is going to continue because if we look up here, it's just multiplying each other with 2. So like this is getting multiplied by 2, multiplied by 2, and so on. So 1, 2, 4, 8, 16, 32, 64. It's going to continue 128, 256 based on the specific register. अब ये register आगे value store करें. These are just slots. सही है, तो आपके slot बढ़ सकते हैं. It can continue up to इसके बाद double होगा 512, then 1024. Yeah, of course, these recordings are going to continue till the end of this month, inshallah. During this, we will try our best to cover up as much of the course. At the same time, you can also look up at our YouTube channel. We do tend to post content up there too. So I've done like chapter number 3. Chapter 1 is done. I might shift to chapter 7 after this. And साथ पे साथ ये videos भी जारी रहेंगी, inshallah. So बाकी, let's see आगे क्या होता है, but inshallah. So let's look up the very first question ki value. This is a very straightforward question. Let's erase this whole thing and isko solve kar de. So the question states that you need to basically convert the denary number 19 and 230 into binary. So अब जो एक तरीका था वो तो ये था कि मैंने आपको बोल दिया कि if I have to divide like 19 by 2, 2, 2, 2 and remainders को मैं देख सकता हूँ. The other method is considering I know कि यार इसको मैंने किसी register में store करना है. So why not assign values? Like I can be like 1, 2, 4, 8, 16, 32, 64, 128. Always go till 128. Okay, my tip. जब भी इस तरह के values आते हैं ना, these are usually less than 256. तो आप 128 तक जाया करो. अब let's say you are up to 128. Now we need to basically fill ones at all those slots जिनको जब मैं आखिर में add करूंगा ना तो I should be getting 19. So like if I want 19, तो क्या मुझे 128 on करना चाहिए? नहीं ना. Like why? If I do 128 plus something, is it possible that I get the value 19? No. Why? Because 128 is way larger than 19 and I don't have any negative numbers up here. Considering I don't have any negative numbers up here, तो मैं सिर्फ उन values को करूंगा जो कि 19 से छोटी हो. So all these are going to become 0. Okay, 16 is less than 19. So let's do this. Now what do I have to add into 16? कि मेरे पास final answer 19 है. I understand that it has to be 3. So अब मैंने वो 1 वहां पे put करने हैं जहाँ पे when I put 1 and then I add them, I should be getting 3. So I see that it's only up here 1 and 1. When I do 2 plus 1, it's going to get me 3. And 3 plus 16 is going to get me 19, which gets me the final answer. So this means ये हमारे पास हो गया and remaining जो भी मेरी values है, those are basically 0. So I get my answer as 000100111. And this is your exact answer. Now, if you write it as maybe 10011, like if you ignore the first 3 elements and you just write it like 10011, ये भी सही है. Why? Because computers, again, थोड़ा सा content topic का ही आ रहा है. Remember, computers always ignores the zeros. So even if you add a million zeros before this this part, like यहाँ पे 0000, इसकी कोई value नहीं है. Only the point 1 is important. Wherever you place 1, it is definitely going to create an impact. So it's very important कि आपको एक बात ये पता हो कि 0 से हमेशा start हो. And secondly ये कि any added zeros are useless. It's not going to do anything. So even if you add them, कोई मसले की बात नहीं. Adding them up here has the purpose कि हम usually computers में 8-bit register use करते हैं. So if you count this right now, 1, 2, 3, 4, 5, 6, 7, 8, we basically fulfill the condition of 8-bit register, which is the conventional register used for especially your IGCSE or O-level examination. But if you only write 10011, that's also fine. See? So now let's do the second one. The second one is exactly the same thing. यही इसी में ही आ जाएगा. But हमें ones ऐसी जगह में put करने हैं where when we add them, we should be getting 230. So 128 definitely yes. Then 128 plus 64, let's add them. 128 plus 64. These calculation skills should be strong because in your exam you won't be allowed to use a calculator, so it's important you do focus on them. See, so 64, this is going to become 2, carry up here, 3, 6, 9, so I get 192. So अब मैंने 192 के बाद, okay, let's say I want to make sure कि 230 हो. Should I add 32? Let's do 2 to 4. 9 plus 3, 2, 1. I get up to 224. Now I need 230, which means अब इसमें मैंने 6 और ऐड करना है. So यहाँ पे 1 आ गया. Now अगर मैंने 6 करना है तो मैं किन दो को करूंगा? I won't be doing this because I need 6. I won't be doing this. I need 6. I will be doing 4. Yeah. And then what should I add into 4 to get a 6? It should be 2. So ये भी हो गया 0. Now if I add all these values, 128 plus 64 plus 32 plus 4 plus 2, you see that I get a perfect answer of 230. You can add them on your calculators too. And this proves why the binary value for this specific denary is 111000011. And this is your answer, 111000010. Now, if the question was the other way around, where maybe उन्होंने आपको binary दी होती, like this, and they might have asked you to give us the denary value, the same cheese apply hogi. You just need to write the binary up here, and then you need to add the values of all those places where the binary is basically 1. So we see that we have a binary up here as 1, फिर यहाँ पे, फिर यहाँ पे, यहाँ पे, यहाँ पे. And so you add 128 plus 64 plus 32 plus 4 plus 2, and you get the equivalent denary number for that specific binary. And this marks the end of this part. Now we look up at part D. Before moving on, is this clear? Is the whole part C clear? Everybody, quick in the chat box. If there are any questions, just let me know, because these lectures are for the same purpose, to clarify your concepts. So we will be having like 3-4 videos or classes per week, inshallah. So don't worry, even agar ek mein zyada nahi hota ek chapter ka, we can have a different subsequent class for that too. But before moving on, everyone, quickly, is this clear? The very first question we did, part C ka, yes or no? Okay, good. Baki, everyone. Ahmed, Ashir, Aram, everyone. Perfect. All right, so let's move on. If you have any questions, just let me know. So yeah, I appreciate questions. Again, this is something I tend to repeat even in my own classes. I appreciate students who ask questions, because the more you ask questions, the better your concepts are going to be, and the higher the chances are that you get that distinction, inshallah. See, so don't worry. If you don't get anything, just straightforward bolo, okay, I don't get this point. So we can go over it again. See, now let's look into the D part. The D part is now discussing the concept of hexadecimal. It's stating that the hexadecimal numbers, what, 35 and 880, are converted to binary numbers to be stored in the RAM. Convert the two hexadecimal numbers into binary number. So now there is a one quick, yeah, dekho, it's easy and it's not easy at the same time. If you are someone who is willing to lock in, give it their best, definitely it's easy. I had the distinction aim since I came to O3, because I was expecting one in O2. I did not get it. It was very much heartbreaking for me. And then I was like, no, I need to get one. And then I worked pretty much a lot. At the same time, you should also pray, because definitely luck and all those other stuff also helps. So like when I gave my exam, it was a pretty difficult exam paper, but I don't know, for some reason I found it easy, and alhamdulillah, it did work. So if you do the practice the right way, inshallah, everything is going to be fine. So yeah, so abhi just focus on the concepts. It's important that you understand the core concepts, क्योंकि ये जो एक चीज है, don't worry, you can easily get it, like literally, it's just you need to focus. सही से ना हो जाएगा सब इंशाल्लाह. So now look at part D. Hexadecimal number 35 is, अब याद रखो, जब भी hexadecimal number को हमने बाइनरी में करना हो, there is one method. इसको हम कहते हैं basically, नाम मेरे जहन से निकल गया, but what we do is that, like for instance, we have 3 and 5. हमने इनको ना separately, we have to put a line in between them. So like I will put a line up here. And what I will be doing is, मैं 3 की अलग से बाइनरी लिखूंगा, and मैं 5 की अलग से बाइनरी लिखूंगा, and at the end I will just combine them. So like अगर मैंने 3 की बाइनरी लिखनी है, I'll be like, okay, 1 2 4 8, and then again 1 2 4 8, the same concept जो previously थे. These are like my denary. अब 3 की denary क्या बनेगी? 0 0 1 1. This is the binary for 3, and for 5 it's going to be 0 4 0, 1. So ये दो हमारे पास है. Now I just have to combine the two, and you're going to see that I get the answer 00110101, and this is your answer for the very first question. बस इतनी सी बात है. The same concept is going to be repeated for the second part, but you see we have three elements up here. We have 8. So we have 8, and we have A, and then we have D. So now what I will be doing is कि मैं इनको ना equally तीन parts में divide करूँ. This, and this. Now I'll be like, okay, 8 की मैं यहाँ पे कर लेता हूँ 1 2 4 8. A की मैं यहाँ पे कर लेता हूँ 1 2 4 8. D की मैं यहाँ पे कर लेता हूँ 1 2 4 8. You should not be intimidated by this these letters A and D. Just remember, A is the equivalent figure for the denary value 10. B is basically 11, C is 12, D is 13, E is 14, and F is 15. Once you start doing the practice, ये आपको खुद ही याद हो जाएंगी. But if it's something जो कि आपको समझ नहीं आ रही, so you can always look up to the lectures which I posted on the YouTube channel. Now 8 का मैं करूँगा तो definitely it's just up here 1, and then the others are going to be 0. A is basically 10, so if I have to represent 10, I'll be like 8 plus 0 plus 8 plus 2, right? So ये भी 0. And D is what? D is 13, so 8 plus 4 12, and 12 plus 1. So I see that I get this binary, which is exactly the answer to this question, because it's 1 0 0 0 1 0 1 0 1 1 0 1. Now you might be wondering why are we going this way and not this way. It's just because आपके question के अंदर ऊपर clearly 8 is the first one, so it's like 8 is the first digit, so you need to write the binary of 8 at the first, followed by A and followed by D. ऐसा ना हो कि आप D A 8 जाए, उसमें आपके marks cut off हो जाएंगे. See, this marks the end of this part 2. Now let's look up here. The part E basically discusses binary addition. Binary addition जब भी हम करते हैं तो there are just some key easy rules, and वो ये है कि आपका अगर 1 plus 0 हो रहा हो, या फिर 0 plus 1 हो रहा हो, या 1 plus 1 हो रहा हो, या 0 plus 0, इनके क्या क्या possible answers हैं. We just need to memorize this. Answers आपके कुछ इस तरह होते हैं कि when you do 1 plus 0, it basically results in 1. सही. And just like that, when you do 0 plus 1, it also results in 1. But when you do 1 plus 1, it results in 0, but you get a carry. Okay, you get a carry. It's the same thing when I do like 12 plus 11. So 12 plus 11 नहीं, इस तरह कर लेते हैं 12 plus 9 कर लो. Say let's do 12 plus 9. So if I have to do 12 plus 9, I see 9 plus 2 is what? It's 11. But I can't write 11 directly. I write 1 up here, and then I take 1 as carry. And वो फिर next part में 1 plus 1 के साथ वो add up होके हमारे पास answer 21 आ जाता है. The same concept is applied up here. So if it's like 1 plus 1, आपके 0 हम यहाँ पे लिखेंगे the way we wrote 1. But we have a carry. And then if you have a 0 plus 0, it's definitely going to be 0 directly. So now let's look at this question and इसको directly solve कर दे. The very first one, 1 plus 0, just the same condition. ये case 1 plus 0, it's going to be 1. 0 plus 0, this condition 0. 1 plus 0, again 1. 0 plus 0, again 0. 1 plus 0, 1. Again, now 1 plus 1 is this condition, which is basically, okay, I forgot one last one, and that is 1 plus 1 plus 1. That is 1 with a carry. This basically only results when you have 1 plus 1 being added, and ऊपर से आपके पास एक additionally carry भी आ जाए. So carry यहाँ पे आ जाए and नीचे 1 plus 1 add हो रहा हो, तो उस scenario में you're going to be writing 1 as the answer, and you will also be having a carry at the same time. So अब यहाँ तक तो हो गया. Now look up here, 1 plus 1. This is the first one. So 1 plus 1 is going to be 0, but I see that I'll also be having 1 carry. So यहाँ पे carry आ गई 1. And now this case 1 plus 1 plus 1 is basically this one, 1 plus 1 plus 1, which basically means कि मेरा answer 1 होगा, but at the same time I will also be having a carry. And now when I do 1 plus 0 plus 0, it's the same case as this one, where I'm like, okay, 1 plus 0 plus 1, yeah, 1 plus 0, which means that my final answer will be 1. So I get the answer as 11010101, and this is your answer. This is your answer, 11010101. Understood? Straightforward सी बात है. You just need to add the values. These are the rules which you need to follow. I would highly recommend that you memorize these rules. Okay, over time, once you start doing practice, you're going to feel like it's not that difficult at all. Straightforward सी बात है. Now we're done with the part E part. Now let's look up here. Part F. The part F basically talks about overflow. See, अब overflow के अंदर वो क्या बोल रहा है? वो आपको बोल रहा है कि okay, an overflow occurs when two other 8-bit binary numbers are added together. Explain why the overflow error occurs. So पहली बात तो ये कि what is overflow error? Overflow error happens when you have a specific register. Register is that place जो कि कोई value store करे, right? So if I have like a register which can maximum, let's say move these lines, आपको straight समझा दूँ. Let's say it can maximum store 255 5 bits. So if it's like a 8-bit register, so remember 8-bit register always stores a maximum value of 255, which is 256 minus 1 भी कभी कभार बुक में लिखा होता है, आप लोगों ने अगर देखा हो तो it's like 2 raised to power 8 minus 1. This 2 raised to power 8 basically yields to 256, and हम उससे एक माइनस कर देते हैं and आपके पास 255 बन जाते हैं. That's the maximum capacity it can store. See, so अब जब हम बोलते हैं कि it can store 255, तो it's the same thing. Like if I have a rack which can only store like 10 books, but I want you to store like 12 books in it, is it possible? No, right? What happens is if the rack is something which does not have some specified ends, like यहाँ पे आपकी सारी books पड़ी हुई हैं, like these are all your books, and now I tell you to add one more book, वो add होगी, and now I'm like, okay, no, what I want you to do is एक और book पे डालो. The moment you push this book into this part, आप देखते हो कि some of the books are gonna fall down. So जब ये नीचे fall down हो रही होंगी, you will see that the values are getting out. It's the same thing. And अब यहाँ पे तो हम ये बोलेंगे books नीचे गिर रही है. In computer science, what happens is that the values basically overflow. ये पानी वाला हम ओवरफ्लो ही बात करें. सो लाइक इफ यू हैव अ कैपेसिटी ऑफ दिस मच बट आप ज्यादा पानी डालो तो आपका पानी बाहर निकलने लग जाता है. वी कॉल दैट ओवरफ्लो. द सेम कॉन्सेप्ट applies up here, where when you add the values, add two binary values and the answer is greater than the maximum capacity it can have, तो आपका ओवरफ्लो एरर आ जाता है. So वो बोल रहे हैं कि why does this occur when you add two 8-bit binary number. अब ये 8-bit इसीलिए हमें बता रहा है कि 255 plus 255 करोगे तो your answer is definitely going to be something greater than 255. There is a possibility for this कि आपकी कोई values होंगी जो कि शायद 240 plus let's say 340 कर दे. So 240 plus 340 is 340 तो नहीं हो सकता. 240 plus 140, that's going to result in something which is greater than 255. And क्योंकि हमारी maximum capacity 255 की है, तो it's going to result in overflow error. So what we will be writing here is the result is greater than 255. Firstly, the result is greater than 255. Once you write this point, आपको 1 mark मिल जाएगा, 1/2. Now for the second point, आपने ये बात लिखनी है कि अगर मेरे पास एक इस तरह के पानी की टैंकी है या ग्लास ऑफ वाटर है जिसके अंदर इतना पानी है, नाउ आई हैव अ बॉटल अप हियर जिससे मैं इसके अंदर पानी और ऐड करूं. आई एम एडिंग वाटर मोर ऑनटू द सेम ग्लास. So initially what I observed was that water is falling down. But what if I increase the capacity? If I increase the capacity, definitely I can store more water. The second point up here will be for the fact that you need to mention that you cannot store the values in an 8-bit register. See? So the value cannot be stored in an 8-bit register. अब अगर आपके पास अगला पार्ट ये बोल देता है, इस सिनेरियो में तो नहीं बोल रहा, बट व्हाट इफ द क्वेश्चन और द एग्जामिनर क्लियरली स्टेटेड दिस पॉइंट दैट व्हाट्स द सॉल्यूशन टू दिस. So you should know the solution to this problem is that you should increase the size of your register or increase the number of bits your register is storing. And once you do that, you will be very much good to go, because now आपकी capacity बढ़ गई. Same concept as this, that you can now literally have way more किधर गया water being stored. Originally itna tha, but now you can also store this, and that solves the problem. So once you write this, you're going to get 2/2. See? Now part G is basically talking about negative Denny numbers. So this was a pretty good question, because if you look up here, we did binary, we did denary, we did hexadecimal, we did addition, and now we are also dealing with negative complementary numbers, 2's complement and all those negative numbers. See, now just look up here. The negative Denary number -22 is stored in RAM. Okay. Negative Denary number can be represented as a binary using 2's complement. Given the 2's complement 8-bit binary integer that would be stored for the give the 2's complement. Okay. Now if I want to store the -22 का वो, तो इसका पता है तरीका क्या होता है? There is one easy method. वो आप लोग यहाँ पे मैं आप लोग के लिए लिख लेता हूँ, and then you can memorize it. Okay. What you should do is write binary for +22, जो कि हमें आती है, straightforward. See? Then you should flip it, and then just add 1. Just like ऊपर हमने addition की है, same to same. So अब ये करेंगे. So I have to make it like this: 1, 2, 4, 8, 16, 32, 64, 128. Say if I have to do 22, it has to be 0, 0, 0, 16 plus 8 is what? 24, 0, 0, and 1. This is, oh sorry, so 25 to me. My bad. ज़्यादा कर दिया. 16 and 16 plus 4, 20, 22. Okay, this is what? This is +20. Now I should flip this. Flip का ये मतलब है make 0, 1 and 1, 0. See, so the zeros are going to become 1, 1, 1. 1 is going to become 0. This is going to become 1, 0, 0, 1. And now I will be just adding 1 into it. So plus 1. And that will give me my result. So 1 plus 1 is what? As per the above rules which we just studied, 1 plus 1 is a 0 with a carry. So we see that I'm going to be getting a carry up here and 1 up here too. Ab 1 plus 1 plus 0 again is the same thing. 1 plus 1 क्या चीज है? एक सेकंड, हाँ हाँ सही है सही सही, इसको अब इग्नोर कर दो, ज्यादा हो गया, इग्नोर दिस, ये कंफ्यूज हो जाता है बंदा. 1 plus 1 is 0 with a carry 1. 1 plus 0 is 1, then this is 0, this is 1, this is 0, this is 1, 1, 1, and your answer comes up as 111 0 1 0 1 0. So you're just going to be writing 111 0 1 0 1 0, and you will be getting 2 by 2 for this. And this marks the end of the question. अगला किसी और से. But this is a pretty good question which literally covered a lot of key concepts. And now before moving on, I want you to tell me, is this clear? Did you understand what we sort of did in this very specific part, how we dive into negative numbers and what did we basically do? You should basically memorize these key steps, such as like एडिशन के वक्त हमने क्या कुछ रूल्स फॉलो करने हैं, नेगेटिव वैल्यूज के लिए क्या करने चाहिए, बाइनरी डेनरी कन्वर्जन्स के लिए. These recordings or these sessions which we will be holding, they will be basically talking more about shortcuts. So we will be diving into those easier things which I found literally easy during my preparation, so that you can implement those concepts into your daily practice. So you should be very much inshallah good to go for the exams. So is this clear? ताकि फिर हम अगले क्वेश्चन के अंदर की तरफ जा सकें. Or is there any questions related to this? Perfect. So now we're done with the 12th variant. Let's do paper number 13 of the same summer 2025. उसको अब हम deal out करते हैं. So we have the summer 2025 paper number 13 opened in front of us. Again, it's the same for IGCSE and O-level, so no need to worry. This question is not related to binary. We have the C part is related to binary. Let's do this. So let's start off with this. Bismillah karte hain. Bismillahirrahmanirrahim. So the first question, if we open up the pen feature, so the very first question up here discusses input output devices. So this is again chapter number 3. So you should be I feel like you should have observed till this point that chapter 1 ke saath usually it's like chapter 3 and chapter 4. See, now the second one is again software to software. So this is chapter number 4, again excluded, not to be discussed at this point. We're coming to point number C, question number part C, which is basically saying that there are two binary numbers which have the values as 000 111 001 and 1011 00100. Now we need to convert them into denary number. Now exactly the same thing which I mentioned in the last part. Remember मैंने क्या बोला था? Values देखो and just see 1 1 कहाँ पे and just add them up. So like we should list it up here: 1 2 4 8 16 32 64 and 120. Why am I going till 128? Because 1 2 3 4 5 6 7 8 and ye bhi count karo 1 2 3 4 5 6 7 8. So usually all these values are in 8 bits, so it's recommended आप 8 bit तक करो. But questions can come for 12 bits, which means कि आपको 256 512 1024 2048 तक जाना पड़ सकता है. Now we will be just writing down the binary values beneath this: 0 0 0 1 1 0 0 1. And now let's add all the relevant ones. So we see that एक one यहाँ पे on है. So like this part, then this part, and then this part. So I just need to add these three. So it's going to be 16 plus 8 plus 1. And I see this is going to get me what? 16 plus 8 is 24, and 24 plus 1 is 25. So the answer to the very first part is 25. Let me confirm. Yeah, 25. And now for the second part, I will be using this one. अब यही नीचे बाइनरी लिख दूं 1 0 1 1 0 1 0 0. I'll be only looking at the ones. So sorry, ये तो one, ये my bad. We'll be only looking at ones. Color change कर लेता हूँ. Let's go with yellow. So this one, this one, this one, and this one. So I need to add what? I need to basically add 128 plus 32 plus 16 plus 4. Now, time to do mental maths. 16 plus 4 is 20. 128 plus 32, दो इधर गया, 130, 160. And 160 plus 20 is what? 180. So you'll just be writing 180 up here and we're getting 2 by 2 for this. These are the answer to this question. So now in the next part, it's basically saying okay, we have these two again, the same, I guess, same, yeah. And we just need to convert the binary numbers into hexadecimal. Now when you have to convert go from basically binary to hexadecimal, it's the same thing. हमने पिछली दफा क्या किया? We took one of those values. Perfect, perfect. We took one of those values and हमने each digit को ना 4 binary उसमें divide किया. So now when we want to go from binary to hexadecimal, हम binaries को 4 के हिस्सों पेयर्स में डिवाइड कर देंगे, पार्ट्स में, बल्कि 4 के पार्ट्स में, एंड देन वी आर गोना काउंट कि यार वो जो इक्विवेलेंट एक पार्ट है वो क्या वैल्यू कंस्टिट्यूट करे. लाइक लेट्स डू दिस पार्ट. सो इट्स लाइक 0 0 0 1 1 0 0 1. So if you see, I can divide this in a group of 4. हमने पहले क्या किया था? हमने ये किया था ना, A9 है तो what I did was A को अलग से 1 2 4 8 किया, 9 को अलग से 1 2 4 8 किया. बट नाउ आई नो कि ये 4 के अंदर डिवाइड हो रहे हैं, तो इसी वजह से मैंने 4 को ढूंढ के उनको अलग से 4 पार्ट में डिवाइड कर दिया. Now in your book there is this one long method where it's like 16 raised to power something multiplied by this, but this is the easier part. This is the very like it's the simplest method existing out there. You just need to divide it, find the nibbles. ये जो एक 4 का ग्रुप बोलते हैं ना, this one group of 4, this is basically known as nibble. So हम nibbles को ढूंढेंगे, and based on that we're going to be finding the equivalent hexadecimal of it. So we know that 1 to 9 तो वो इसी तरह hexadecimal रहते हैं. A is then 10, B is 11, C is 12, D is 13, E is 14. Always write this. I always recommend that you should write this. Usually बंदे को नहीं पता चलता वो गलती कर लेता है. So there is no chance to make a mistake in such an easy question. So do tend to do write this A से लेकर F तक की equivalent denary values on your exam paper. See. So now up here 0001. So 1 2 4 8. This is directly 1. So हमारे पास 1 आ गया. Because 1 is less than 10, तो हम इन letters में नहीं जाएंगे, हम directly 1 करेंगे. And यहाँ पे we see कि it's like 1 2 4 8. 8 plus 1 is what? It's 9. So हम यहाँ पे भी because it's less than 10, तो हम letters में नहीं जाएंगे. So the answer to this part is 1 9. हम इन दोनों को बस combine करेंगे. So 1 9. दूसरे के लिए देखो. दूसरा is like 1 0 1 1. And then it's 0 1 0 0. अब let's count it. ये जो है ये तो 4 बन गया. Okay. And ये क्या बना? This is 8 plus 2 plus 1. This is 11. But I cannot write 114, right? Because 11 is not defined. So because 11 is not defined, हमने ये बोल दिया कि okay, कंप्यूटर ने ये बोल दिया, अच्छा बंदा है, उसने बोल दिया 11 को B लिख दो. So I will replace this 11 and I will write it as B. So my answer is going to be B4. And that is how you get the binary number, the hexadecimal number for a specific binary value. समझ गए? Now, the third part of the same question states that a logical right shift of 2 places is performed on the binary number this. Give the binary number that will be stored. Okay. A logical shift right or left basically means कि आपके जितने ones and zeros हैं उनको या एक एक right पे ले जाओ या एक एक left पे ले जाओ. So like if I have this value 1 0 1 0 0 1 0 0. If I say logical right shift, this basically means कि जितने ones हैं इनको ना हर एक को ना right पे ले जाओ, हर एक चीज को right पे ले जाओ once, क्योंकि इसने बोला है ना अच्छा twice का बोला है, तो which means कि एक दफा ले जाओ एंड फिर उसके बाद एक दफा फिर ले जाओ. So अगर मैं इसको बारी बारी एक को उधर उधर लेता जाऊंगा, so let's make these slots. सही है, 1 2 3 4 5 6 7 8. ये 0 किधर गया? ये तो आउट हो गया. So when like this 0 comes up here, जब कोई चीज इसके लिमिट से आउट हो जाए ना, इसको हम डिस्कार्ड करेंगे. So हम इसको लेंगे नहीं. This value basically gets discarded. Why? Because ये उस 8 वाली रेंज से निकल गया, तो निकल गया. यहाँ पे क्या है? यहाँ पे ये वाला 0 है, ये 1 इधर आ गया, फिर इसके पीछे ये 0 आ गया. It's kind of repeating the same whole thing. एक सेकंड, कुछ ज्यादा तो नहीं गया. 0 1 0 0. Okay, yeah, एक एक्स्ट्रा लिख दिया. This is 1. So 1. And then you get this 0 and then you get this 1. But you might be like saying, sir, कि आखिरी भी तो empty रह गया, यहाँ पे क्या करेंगे? तो remember, whenever we are dealing with logical shift right या फिर logical shift left, whenever you have an empty slot left, जिस तरह यहाँ पे रह गई, तो उसको हमने 0 से replace करें. Why? Because remember, मैंने आपको क्या बताया था कि zeros are useless. They won't do any good to your program. So even if you add a 0, कोई फायदा नहीं होना, कोई चेंजेस नहीं होने. So just because of the same reasoning, we are going to be putting up a 0 here because आपकी वो bit पूरी हो जाएगी. The whole register is now going to be filled. If you don't put a 0 up here, the problem is आपके register में एक slot empty रह जाएगा, which we don't want. And now this marks the end of one logical shift right. LSR भी बोला जाता है, which is logical shift right. But the question stated that you need a twice वाला. तो अब इसको एक दफा फिर भी मैं कर दूंगा. So this 1 basically comes up here. इस तरह ये इधर आ गया. This 0 takes up this place, so ये आ गया. This 0 comes up here. 1 comes up here. This 0 comes up here. this one goes up here and this zero comes up here and then we see कि एक आखिरी फिर रह गया उसको फिर हम zero से replace कर देते हैं. And so your answer is 001001001001001001. Yep. And this is how you're going to be doing it. Now one important point to note here is कि जब भी आप, this is not relevant to this question though, but let me just clarify this too. um, किधर गया, यहाँ पे लिख देते हैं. Let me erase the whole place. Remember, whenever you do logical shift right, every logical shift towards the right side means that you are dividing the value by 2. Dividing the value by 2. By 2. Or you can also say half the value. Now, in your exam, there sometimes is a question which says, कि what was the impact of the logical shift right? So, उसमें आपने लिखना होता है कि it divided the value twice. या अगर इस सिनेरियो में it was 2 places to the right, so it divided the value by 4. क्यों एक दफा भी 2 से हो गया फिर भी 2 से हो रहा है तो 2 into 2 it's like dividing the whole value by 4. And just like that, whenever you move logical shift but towards left side, the left side may your value is getting multiplied. Value is multiplied by 2. Yeah, doubled. And if you count the binary, wise, अगर इसके अभी मैं कोई वैल्यू निकालूं ना प्रॉपर जो भी इसकी डेनरी बनी है उसको मैं डिवाइडेड बाय 4 करूं उसकी बाइनरी करूं ना तो वो ये बन जाएगी. यू कैन टेस्ट दिस इन योर फ्री टाइम सी. बट दिस इज एन इंपॉर्टेंट कॉन्सेप्ट, आपको पता होना चाहिए. लॉजिकल शिफ्ट टुवर्ड्स राइट साइड मींस डिवाइडिंग द वैल्यू बाय 2, टुवर्ड्स लेफ्ट साइड इट मींस मल्टीप्लाइंग बाय 2. Now let's look up here part D. Part D is again 2's complement. 2's complement जब भी आ जाए तो it usually refers to negative value. See, it is saying that 1100 is also stored. Complete the 2's complement equal to denary. अच्छा, so याद रखो whenever हम usually बोलते हैं ना, usually we go like 1 to 4 8 16 32 64 and 128. This is the conventional one's complement. When we talk about two's complement is a concept which was introduced when you have to deal with negative values. See, so whenever we have to deal with negative values, what happens is that this positive 128 becomes a negative 128. So now when we want to, let's say, find out what's negative 50, तो हम क्या करते थे, हम यहाँ पे 1 कर देते. So it's like 128 के अंदर आप क्या चीज ऐड करोगे to get, let's say, negative 50. So we see कि अगर मैं वही मैथ्स वाली कैलकुलेशन करूं तो इट्स लाइक 128 में से जब आप माइनस करो 50 क्योंकि उधर जाएगा पॉजिटिव होगा, सो यू गेट द आंसर एज लाइक 128. 50 आप यहाँ पे कर लो, 8 आ जाएगा एंड ये 0 के 1 आ गया. सो 12 में से 5 किया तो आपके पास 578 आ गया. सो यू जस्ट नीड टू पुट ऑल द वंस सो दैट वी गेट द आंसर एज 78. सो लाइक 64 हो गया. 64 के अंदर आई नीड टू ऐड लाइक 14 मोर. सो 8 4 12 and 12 plus 2 14. So ये आपके पास जो ये वाली बाइनरी बनी है ना, this is for negative 50. How do I get to know कि ये negative है? Because now in this scenario I have the 128 वाला element as negative. So if I have to represent the same concept up here where they gave me this binary number and इससे मैंने identity निकालना है तो वो क्या होगा? Same to same चीज. I will be listing down the values. So 1 2 4 8 16 32 64, and now rather than having 128 I'll be listing it as negative 128. And because उन्होंने हमारे negative 128 को 1 किया हुआ है and question में clearly stated है 2's complement, तो मुझे पता लग गया कि the answer is going to be negative. So 1 1 0 0 1 0 0 1. Now आपने सिर्फ ऐड करना है. In your book, या maybe if I'm not wrong, back when I was preparing for the exam, there was one other method too, which was very confusing. I'm not sure if it was in the book or not, or maybe our school teacher taught us, but it was very confusing. Now, what you should be doing is कि इसको उसी तरीके से ऐड ही करो. So like minus 128 plus 64 plus 8 plus 1. So if I add them, I see like, okay, minus 128 में मैं 8 add करूँ तो that's what? Minus plus 6 गया तो 70 बन गया and 2 गया 72 and then 73. So I have to add this. So अगर मैं ये करना चाहता हूँ, अब मैंने minus 128 plus 73, which basically means कि मैंने subtract करने. These are going to be subtracting each other, right? So 73 से आप 128 को subtract करेंगे. अब minus 128 plus 73 is the same thing as stating 73 minus 128. Okay, 0 1 28. Now if I do this, क्या बनेगा? अब आपने ये करना है. एक सेकंड, how do we subtract it? My bad, जहन से निकल गया. But yeah, आपने इसको subtract करना है and the answer is going to be x is equal to यार I usually use calculator for this, but you just need to subtract it. Let me use the calculator. So it's going to be 73 minus 128 and we get the answer as minus 55. And minus 55 basically अगर आप इस तरीके से भी करना चाहो ना तो that's also possible. It's like minus 128 and आप उससे how do you subtract negative values? Whereas I guess, oh yes, ये कर दो ना 8 plus ये 5 हो गया and 12 minus 7 is what? 12 minus 7 is also 5. So yeah, my bad. But because it's minus तो हम minus यहाँ पे भी लगा देते हैं. समझ गए? So now the answer to this question is negative 55, which is the denary value for this specific binary integer. And this is how you're going to be dealing with negative binary values too. If you don't understand the concept of two's complement, one's complement, I would highly advise that you go back and watch those recorded lectures जो कि मैंने post किए हुए हैं. If it's clear, just let me know. Is this whole question clear? All these three, four parts which we did. At this point, it's like 9:52. We won't be continuing. If you have some general questions about computer science, क्योंकि पहला दिन था, तो you guys can ask. Apart from that, I would highly encourage that you all should join the class by 9 sharp. I sent the link at like 8:55. तो जितना जल्दी आप लोग आओगे, the more time you will have. Today we started a bit late. So, and also it was the first class. So from tomorrow onward, we will be diving into the same topic number one के question tomorrow भी inshallah. And like tomorrow's class will be again kal Wednesday. Yeah, we will have a class tomorrow. See, so unless I don't message you guys, you can assume कि kal class inshallah hogi. And in that we will be again diving into the same concept chapter number one के before moving on to chapter number two उसके बाद. See, so आप लोग मुझे बताओ, is this clear? The whole concepts which we revised and did some practice questions of आज related to binary, two's complement, one complement, hexadecimal, conversion, and all that. Perfect. Any questions regarding anything, like regarding CSS general, regarding any other subject, anything? All right, seeing none. Okay, that's perfect. Great to know. Um, okay, so it's 9:54 per se. Let me end the recording, and you guys can